Okay.
That
Yeah, go ahead.
has it been raining where you live?
Yeah, yeah, it's been raining all over, I think, in Melbourne. Definitely here in Tarnate.
Mm.
But yeah, good news is we host these indoors rather than outdoors. Although I did have one storm that was kind of bad enough to actually short my PC at one point. It didn't cause any damage, so I have since decided to buy a proper switchboard, proper circuit breaker thing for it, so it's not going to be impacted in the future, hopefully.
Yeah, mine a bit.
Yours got hit?
Mine a bit weird. The circuit breaker or short preventing thing.
Yeah, yeah,
Yeah,
yeah. Okay, as
I
long
should
as.
probably replace mine.
But no damage, yeah?
Yeah,
Okay, sweet. It's always the worry, right? It only takes one wrong voltage somewhere for something important to break.
yeah.
But anyway, so we are still in our SAC preparation phase. So I figured since we've done most of the extended responses of the chapter review section, I figured I could start pulling out in reverse order the calculus practice SACs, the tech active ones. Because I think you've already started looking at least the first one. Did you make it all the way to the last one, or is this a good place to start? Because if so, then we could start from here, and that way you can still have at least the second one to practice on your own if you need to, for both of you, by the way. But okay, cool. So I've got it starting off at the external response section. Also, let me know if you want to practice multis or anything like that. Okay, those can also be little like quick fire things that could be worth having a look at. But I'm just aware that most of you are mainly worried about extended response. But if you do want to look at multis, anyone, let me know. Otherwise, let's start here. Question 1a. Proving the height of the block is given by that, yeah, given by that function. So we see we have all of the dimensions of the block, a rectangular prism, in x's and h's. We're told the total surface area as a number, and we're told to use that information to rearrange, basically to get h in terms of x, effectively. Even if we don't know exactly the path directly to there, do we have any ideas on how you might start walking down that path?
I get up the surface area for a rectangular prism and input these values,
Yeah, exactly right.
include including the total surface area that it gives at the bottom.
Yeah, that's exactly right. We've got the total surface area as a single value. We've got dimensions of the rectangular prism in terms of x and h, so finding a way to marry those up together, really good idea. So we need to do exactly that, getting our surface area equation going. So how do we do the surface area of this rectangular prism? I'll give you guys a moment to have it written out if you don't already.
Um, the formula for surface area of a rectangle is I'm sorry, a cuboid is 2LB plus LH plus BH.
Yeah, so basically two copies of each unique face on it. You're going to have two copies of this front face, two copies of this top bit, and two copies of this side bit over here. Yeah, exactly. So let's give that one a shot. So we've got 6480 for our total. 6480. Let's go off the 2xh first. then we can do the 5x over 2 and the h. 2 bracket 5x over 2 and h. And then lastly we've got 2 copies of the, what is it, x and 5x over 2, so 5x squared over 2. 2 bracket 5x squared over 2. Simplifying further, we could take a common factor of 2 out, though I'm seeing that the h is already kind of, everything looks joined as is. So let's just do some simplifying instead. So it's going to get us 5xh and then 5x squared. From there, 2xh and 5xh for the total of 7xh. And getting the h on its own is now pretty chill. So 6480 minus the 5x squared and then dividing the remaining 7x. Double checking, 6480 minus 5x squared over 7x. Yeah. And that's it. That's enough. Nice. Okay. Actually what I'll do is I'll drop this whole document in, so yeah, in fact I'll even drop the answer one as well, just in case you need a quick hint to pick you up. That way you can scroll directly and have your own copy rather than having to rely on me scrolling back and forth. So this should be downloading quickly in the chat, because we may or may not need to refer back to some of the previous questions now that we are doing a sequence of extended response. So let's have a look. Part B, volume of the block. We're already given the equation for it. Given that volume and x must be positive, find the possible values of x. Okay. Possible values of x. We've seen that a couple of times before. So we got a new equation, volume equation. Possible values of x is usually referring to the domain of the function. It does maybe seem like a bit of an odd question, given that they're saying, hey, x is greater than 0. So that implies that there's something else that we should possibly be worrying about, other than just saying x is from 0 to infinity, non-inclusive.
Do we have to consider that x is length?
That x is the length? Yeah, basically that's what it's going to come down to. So x is going to be related to both the length and I guess the depth of this shape. Yeah, absolutely. That's one.
So is it like a optimization problem?
Kind of. It's going to be very similar to what you do in the optimization problems, which is, you know, you get your equation for the thing you're trying to maximize or minimize, which, if you have a peek at part D, is where that's headed. But there's one step in that process where you want to also figure out what's the effective domain of the shape or the thing you're trying to optimize. This will have a very similar approach as to how you get your possible values of x here. For the it tends to be a bit easier for the other ones. It's a bit harder to conceptualize how x is going to be bounded here. For instance, we're not going to be able to go straight to... Well, I guess you maybe could. Right, you could put this in to your surface area formula thing and try to see what would get it to 6480. Basically put, you're not going to be able to have infinite length or depth because you have a certain max or specific surface area that you've got to achieve. Volume's going to have similar things going on with it as well. This is tech active, so we can rely on our CAS tools for this as well. What might be something we would do to start exploring this?
Graph it.
Graph it. Yeah, exactly. So let's do exactly that. X times bracket 6480 minus 5x squared over 14. You do have to also play a little bit of setting your window settings appropriately. Apparently this one is quite large. Gee, even larger than that.
Maybe you can use the. You can set the exact. We can set the domain part and then use menu 4a thing
Oh yeah.
to set the y-axis.
I found that that sometimes does weird things, but I guess, yeah, setting the domain, I think that is what it is, isn't it? You want to set the domain as far as you can and then auto-fit it from there.
Yeah.
Yeah, it's a good idea. Let's just chop off this minimum. Apparently, not that bad. Oh, whoops, that's the wrong thing. Either way, that's enough information, because all we're looking for is that bit there. Alright, we're looking for where is the whole thing positive. So in other words, we're looking for the x-intercepts of our graph. So now that we know that, even though for some reason this is still not enough scale. Oh, there we go, that's a decent scale. Yeah, we could go ahead and find our x-intercept. Hopefully it's not a decimal. In this case it comes out to be 36 quite nicely. So as far as showing you're working on this, this is a 2-mark question. You're essentially, I guess, just saying v of x equals 0. That's going to get you x equals 0, that, and maybe all you're going to do is cross out the invalid option, saying that that's where x is negative. And then from there, you say something to the effect of, therefore, possible values of x are going to be between 0 and 36. Because that's the section of the graph where both x is positive and volume is positive. Cool with that? If so, let's move on. dv dx. That'll be pretty chill. Or maybe not, given that it's 3 marks.
I guess it's because of the form that it's in, or that we have to give it in.
Yeah, let's
So
find out.
ax squared plus b.
Yeah, what is it about this that makes it weird?
Doesn't seem very weird.
Exactly, yeah. Doesn't seem too bad. That gives you a pretty quick and easy. A is negative 75 on 14 and B is 16,207. What could they possibly get 3 marks out of for this? Find dv dx, express your answer in the form dv dx equals ax squared plus b. A and b are real numbers. They look pretty real to me. 3 marks. I guess the next best bet here is going to be just doing it via algebra. That's the only other way I could imagine showing your 3 marks. So I guess going through your product rule approach and showing that you know how to do it that way. At least I guess the advantage is that you know what it's supposed to end up at. You can use your calculator to handle any of the complicated parts of it. So you might do a sort of tandem approach if you need to, where you're just saying, okay, I'm doing my product rule, so I know I'm going to have, yeah, let's go with u equals 5x on 14. Well, maybe that's the thing that was a bit weird when doing it, understanding that they're both divided by 14. Maybe 6480 minus 5x squared on 14, and if you can't be bothered diffing any one of these, which shouldn't be an issue, you can cas it out. That one's going to be the 5 on 14, the dash, those are going to disappear, and now you're going to have negative 10 on 14, which is negative 5 on 7x. Then from there, demonstrating the product rule. So it's the product of those two things. Yeah, sure. 5 on, well, maybe we'd say first dv on dx. 5 on 14 bracket 6480 minus 5x squared on 14 plus the other way around, so 5x on 14 times negative 5 on 7x, and then just sort of going from there, maybe getting the cas to simplify this one for you, and then you go from here on that one. So let's see what that might look like. If I just punch that first bit into the cas, go 5 on 14 times bracket 6480 minus 5x squared, which is also on 14. It's not going to work, is it? Fine, we'll just factor it on the bottom. Just really what they want us to do. They're not actually showing any working on the answer sheet. This was a VCAR exam. What do they want? I mean, I guess this is the kind of stuff you would do using your cas to simplify steps at each stage and then just combine it all together at the very end. dv dx minus 25 bracket x squared minus, well, maybe we wouldn't do that one actually, we'd expand that out. I'll just quickly cas expand it. Menu 33. So that term actually ends up being 8100 on 49 minus 25x squared on 196. Then this one, 5 5 is 25, x squared 14 by 7 on 98. And then again, I guess, one final step of getting the cas to simplify and condense that fraction down. I could keep going on this, but I think you guys are getting the gist of what you'd be doing here. Eventually, it'll all combine down into the final answer of what you want.
I feel like, actually no. I think the 3 marks would be first getting the derivative. Actually, wait, no. Getting the derivative and putting it in the form that's asked, but
Well, yeah,
that step was one. That was literally one step in the CAS.
exactly.
So yeah. Okay.
I'm going to read
I
more
have
about the
no idea.
report. So, this question was done quite well. Some students attempted to find the derivative using a written method and made algebraic errors. So they're almost chastising that. Others had the correct answer with incorrect working. Some incorrect answers were all as a big fraction, and then no. Oh, some poor people didn't have the fraction part of this. They just said minus 75x squared plus. Oh, because they thought they were ripping off. Because they thought a real number might mean an integer. That would suck. And some gave the answer as decimals, so they control entered on that. Yeah, and even looking at the marking scheme, it's like 5% of people got 1 mark, 2% of, 5% of people got 1 mark and 15% of people got 2 marks for this. It was pretty split, either or nothing for the most part. But yeah, this one's kind of confusing where the... Oh wait, actually no, I might be able to figure this out. I'll look into this later because I'm pretty sure they also release a marking guide, at least with the more recent, the recent exams. Maybe what I'll do is, yeah, I'll get you guys to have a look at part D, and I'll see if I can chase down which exam this came from. Yeah, let's try that. So exact values x and h if the block is to have a maximum volume. I'll have a look in the background, see if I can find the marking guide. I have a feeling it was too old for it to have the marking guides attached, because I haven't seen it, and I've been digging since up until 2013. Yeah, okay. I think we'll just leave that there, unfortunately. Okay, how are we going with this one? Maximizing volume and finding the exact values for which give us our maximum. What kinds of things are we trying to do?
Find the maximum. You need to look at maximum
Yeah, find local
of
maximum.
the graph.
Of the V graph, yeah, not derivative, but the
Yeah.
original graph. You can use derivative of it, of course, but it
Yeah.
can be kind of nice to just start with some initial idea of just getting it from the analysis tool, the graphing tool. Now you're going to get a decimal, sure, but at least it can help you validate maybe the direction you're headed in. So it's going to be roughly there as far as what we're looking for. How are we going to get our exact values?
Control enter, and well, H, we've been given the formula.
Yeah, we've got a H formula, yeah.
Yeah. Um, yeah.
We do need exact for this though. This pretty much always defaults to decimal. I don't know, unless you know if there's a way to get this exact. I don't think there is on the graphing tool.
On the graphing tool, I think there was a way. I remember doing it.
Oh yeah.
Yeah. I think someone in my methods class, they figured it out.
Oh shit.
Yeah, I don't exactly remember how, but I remember doing it in class. I think we set one of the values to wait, no. Actually, I don't have my cat, so I've got no way to trial that.
Yeah, that's fine.
Yeah, my
well,
SAC's still going on.
Yeah, if you've seen it happen before, then I can look into it in more detail on the actual on the document, the user guide for this CAS.
Yeah.
Because if you've seen it done before, then that's good. But yeah, otherwise, other methods involve using fmax or maybe derivative equals 0. Any of those will get you there. My personal preference has always just been fmax, just because I don't have to think too hard about it. All I got to do is put in the domain that's associated. Even if you do a sort of half step of the domain, just knowing that if I set it greater than 0 for x, I'll find the value I'm looking for, because I know the positive portion of it's on the left hand side over there anyway, so I don't necessarily have to be super specific of 0 to 36. I can just make sure I'm limiting the parts where I definitely don't want it to be. So that's going to get us the x coordinate, which is step 1 of what we need. Step 2 for the h bit, you already mentioned it before, we have the h equation, so all we're going to do is put it into our h equation. So if h is that big fraction, then now we have h being 6480 minus 5 x squared on 7x, and if we go ahead and fill that in, we'll now get our h. Save us from having to sub it in 2 different spots or define a whole other function for it. And that'll get us our 2 things. We needed the x and the h, not the actual max volume itself. Those are the only 2 things that were required. Any questions there? Yeah, go for it.
As I don't have my CAS with me, I'm trying to use GeoGebra. Do you know how I can change the dimensions of the graphs so I can fit them all?
GeoGebra.
Yeah.
I don't even know if I've used it before. Let me. Oh yes, okay. Let me. It's the.
Wait, I think I clicked on something and the thing came up.
Cogwheel at the top right.
Don't have. Okay.
Yeah,
I have no idea what I clicked, but I got the thing.
Oh, you got it?
Yeah, I have no idea what I clicked though.
Yeah, I'll show you how I know to do it. This is what you're talking about, yeah? GeoGebra calculator?
Yeah.
Yeah, this cogwheel up here, open settings, and you got all the dimensions.
Oh. Okay. It opened up automatically for me. I have no idea how that happened. But thanks.
No worries. Okay, let me pull this back over. Cool. Okay, next up we have a hyperbola. Sketching the graph. I think, yeah, there's really not much to be talked about there. We have the CAS, we can just use the CAS to get the sketch going on. So maybe we'll, I'll get the graph going, and then in the background you guys can have a think about BI and so on. First I've got to make sure I kill the definition of X. Alrighty, here's our hyperbola. First up, find f dash. I mean, again, that's a one-liner. Done. Range of f dash. That's where we're going to start running into maybe more challenging, even though this is just a truncus. What's our range going to be?
All real numbers excluding 3.
All real excluding 3. Maybe for the hyperbola, this is saying range of f dash.
Oh, f dash.
Yeah.
Okay.
So that's the one that I got on the CAS, that truncus. So we know from our reflection terms that it's a downwards facing truncus. And we know from our translation terms that the only translation in here is a shift right by 2. No vertical translation to speak of. Range of that.
I'm trying to do this with GeoGebra and yeah, I'm having quite a bit of trouble.
Yeah, okay. Let me see. So I guess first up, this one, it's easy to probably get sucked into the idea of needing to use the CAS for it all the time. This is a truncus. It should be something you'd actually be able to sketch. If it was like in a tech free, for instance, you would probably do this without thinking. But as far as how you would get it on GeoGebra, it's going to be a lot of bracket spam. So -1 bracket.
I've got the thing. I've got the equation, but I just can't copy it as easily.
Copy it.
I um uh I think I think I can use the solve thing.
Solve for.
Yeah, it should be the same as every other CAS. So the solve equation variable.
Yeah. We're doing range here.
Yeah, I'm trying to find the inverse with that.
I think I'm probably overthinking it a little bit. Because if you have the graph on this one, then all you're looking is all the possible y values of it. Dash does not mean. Oh, I think I know what you mean. Dash is not inverse. Dash is derivative.
Oh, wait. Okay.
Yeah.
I think I'm. Yeah. Okay.
I think you just misinterpreted what the dash meant there.
Yeah, I definitely did.
Yeah, that's all good. But yeah, so for this one, once you have our graph, we can clearly see it's going to be all real negative numbers here. Otherwise, you could say negative infinity to 0 with both of the round brackets there. Cool. Okay. Range of f dash, and using the result of double I, so the fact that it is from negative infinity to 0, explaining why f has no stationary points. Kind of like that question. So you have to mention why the results of part double I are relevant in explaining why there's no stationary points. One of the things I would start considering would be, well, how do I prove if I have stationary points?
Stationary points mean the derivative does not have any. The derivative at that point is 0. So as it does not touch 0, there's no stationary point.
Exactly right. Yeah. The range has 0 as exclusive on the derivative range. And so if it's exclusive, it can never equal 0, and because it can never equal 0, there should be no stationary point. Yeah, that's exactly it. Nice. Okay, now for something that looks like a bit of a mess. So we have some point on our function f of x, so f of x is going to be the hyperbola here. Show that the equation to the tangent of that hyperbola is written, or could be written like that. So rearranging, rather than just having a y equals mx plus c, we still have our y and x in there, but they're going to be factorized in such a way that they look like a mess. Nice. 2 marks, so we don't have to give, we don't have to do the whole thing by hand. We can use the CAS to get a good start and get some initial ideas on how we can get that first mark of working. Before even thinking about the form of what it's like, it's probably a good idea to think about, okay, well, how would I find the tangent of this function anyway, at some point, if I did know what that point was? CAS or otherwise. One of the things you can do with the CAS is you can force it to use it to do a tangent line, not just for a known point, but also for an unknown point. So you can actually get ahead of the curve and go ahead and force it to do a tangent line of our f of x, point p, because in this case it's using p as the x value. That's going to get us our generic tangent line as is. Yeah, Nihal?
How do I use tangent line function again?
Yeah, so the syntax for it is the function you're trying to find the tangent at, comma x, just because you want to tell it to find it at an x location, and then the next variable is what the x location is. So if I knew I was taking it the x coordinate of 1, all I would do is put that as a 1 instead.
Okay.
That's
Yep.
the syntax there. Is that what you're asking?
Yep.
Yeah, cool. So by putting a p there, I'm saying, okay, well, now give me a generic tangent line for all possible values of p, which is what we're looking for here, right? Because you can see there's still p in the answer. If you're still worried about getting that Markov working, you shouldn't be, because you have to rearrange this still to make it look like that final answer. But if you're still worried, you could go through the whole the derivative and shoving in the point p to get the gradient of the linear, and shoving in the point pq to finally get the y coordinate of it. Just making sure that you write the q in terms of p back again. More steps that aren't going to be required here, because you do have to still do a lot of rearranging to get there anyway. So let's say we're starting at this spot here. All we're going to do is try and figure out how we're going to get the y's and x's in the right spot, as well as the p's in the spots that they need to be. So let me have a go at copying this down. Okay. So we got 3p squared minus 11p plus 11 all on, let's rewrite that a bit, p take 2 all squared minus x on 2 bracket p take 2 all squared. And all of that is equal to y. That's our linear. Might not look linear, but if this is a function of y in terms of x, then, well, the only x in here is degree 1, so it is still technically linear. There's your gradient term. But cool, we got to make it look more like what's on that, what's described. How are we going to start getting there?
Maybe use the expand function.
We could do expand here. I think there's probably a decent idea for it, because although the left hand side of what we want is a squared term, it's not our squared term here. So probably expanding now might be a decent idea to try and collect terms in a way where we can finally get that left hand side grouped bit. So yeah, let's try that then. So all of this is going to remain the same, p squared minus 11p plus 11. That's going to get p squared plus 4 minus 4p minus x, and then 2 times exactly that. So that's going to be 2p squared plus 8 minus 8p. Maybe not. Maybe we'll still keep these as looking similar. What else?
Maybe you can join the terms. So
Joining the terms?
make them,
Yeah.
yeah, make them like fractions. So
Yeah, sure.
multiply the first term by 2.
Yeah. So it's going to get us 22p plus 22 minus x all over the same denominator, 2 bracket p squared plus 4 minus 4p. Okay, sure.
we can make the numerator look like the denominator.
Make the numerator look like the denominator.
Yeah, at least one of the factors of the denominator.
So have the same
Maybe
factors.
there is an x though.
Yeah, combining the fractions kind of makes it hard to do any factorizing out afterwards. I mean, we could put a pin in this one and try to do it maybe here. Can we factor? Let's Cas factor that top one, see if we can spot anything. 93 factor. I have 3x squared minus 11x plus 11. Okay, well, that actually can't be factorized. Or at least the factors would be like roots and stuff, if they do exist maybe. So that's not great. One of the things I'm noticing is the y isn't exactly on its own. You got this y take 3 and it's also got another term multiplying it. So you got stuff on the y side. I would consider starting moving things over to the y side. So something like 2 bracket p squared minus 4p plus 4y is equal to 6p squared minus 22p plus 22, and that's minus the x. Now it should be a minus 2x, so I guess multiplying both sides by 2 would get that. What else is going on? Maybe expanding wasn't a great idea just yet. What if we put a pin in those and we just start by multiplying both sides by the p take 2 squared? Let's see. So if we do that, we'll have p take 2 all squared times the y is equal to 3p squared minus 11p plus 11 minus x on 2. Is that going to get us any closer?
The 2p minus 4 is double of p minus 2, so could that be something?
The 2p minus 4 is double of that.
Yeah.
Could it be something? So 2p minus 4 is double of p minus 2, but to get it in there, you'd have to square it on the way in.
We can do 2 squared. Sorry, we can multiply that by 4. Because 4 squared, 4 is just 2 squared. 2 squared times p minus 2 the whole squared. That we can multiply the 2 and p minus 2 because both of them have the same power, right? Can we do that? Alright.
Yeah, so you're trying to figure out a way to basically have a coefficient in here that you can distribute in there. Yeah. Okay, and multiplying both sides by 4
that
seems
alright. That would also solve our x.
Yeah. Yeah, so multiplying both sides by 4, we're going to get our 2p take 4 all squared y. So multiplying everything by 4 here, so 4 3s 12. So minus, 44. plus 44 minus 2x. Okay, sure. It's going to get us that. Getting stuff on the y seems tough.
I think we can multiply both sides by wait. We can subtract 3 times 2p minus 4 the whole square.
Say again, sorry? Subtracting what?
3p minus 3 times the whole of 2p minus 4 squared. So we can
Subtracting
do y minus 3. Yeah. We subtract that part from both sides. So minus 3 bracket open, 2p minus 4 bracket closed, squared.
Okay. And then
No, we subtract from what we already have.
oh, you're subtracting that on there. So basically,
Yeah.
that would mean if you have one of these and taking away 3, you now have a net minus 2 on that. So maybe taking 4 instead, if you wanted to have a net negative 3.
I don't think I got you.
Because you were taking away 3 of these from one of those. Oh, well.
But can I use the
No,
annotate
sorry, you're right,
too?
because it's got a y on there. It doesn't actually work the way I said it did. Yeah, no, that's fine. So you're taking away 3p, so yeah, that. You're now going to have 12p squared minus 44p plus 44. Take 2x, and then take 3 bracket 2p, take 4 all squared. And that would get us, yeah, y take 3 copies of that. And because this is a big negative, with any luck, that's going to cancel out a lot of these things. Let's find out. So we got a 12p squared here. I guess the first thing we'll see is, does this expand out and cancel down? So let's go 2x all squared. It's going to get us 4x squared times 3. Yeah, okay. Cool. This looks like it's going to work. That was a nice idea. So 12p squared minus 44p plus 44 minus 2x, and then expanding this bit out. 3, 3, so expand negative 3 bracket 2x, take 4 all squared. That becomes negative 12p squared plus 48p minus 48. So that's looking pretty good, because, I mean, good is relative, but point being that these are going to cancel down. This is going to have a net 4. Yeah, net 4p. And this is going to have a net negative 4. Is that all we needed? Holy shit, look at that.
Yep.
Solid. No, good idea. Good idea on subtracting 3 of that and then using the yeah, using that factorizing. Nice. I think that might have actually taken me a while to consider. Like one of the things I was thinking of doing was actually going back and doing the whole y equals mx plus c version of the tangent line, because this was starting to look like it was like too complicated to work with, this version of it. So yeah, I'm actually quite impressed that you managed to find a nice solution to get there. Good job. Yeah,
I was thinking of like making it into a normal y equals mx plus c equation,
yeah,
like
yeah,
the part that's given,
yeah. I mean,
and
this is
then working from there.
y equals mx plus c. Yeah, maybe keeping that q in there for longer might have been helpful for the complexity of it, perhaps. Let me see, because I did have a peek of the answers, at least the ones that were provided. Let me pull that up if I can find it. Oh, I clicked way too many tabs. Screw it, let me just change the screen share over. So this is what I had in the background there, and they did actually contain that queue. But because you're doing the y take y1 equals mx take x1 approach, you actually already have that x take p in there. And like you have it in these sort of, the numbers just sort of are in an easier format to simplify. But no, we made it there anyway, and you're in the top 10% of people to solve that question. It's pretty cool. But yeah, looking at it now, probably would have been better to not use the CAS tangent line thing to cheat our way through it. Perhaps better to do the y take y1 equals mx take x1, the gradient point formula. Cool. Okay. Just jump back over. Let's see, we should probably be able to do one more. Maybe not if it's 4 marks. I guess we'll see. Maybe we'll talk about it instead. Find the coordinates of the points such that the tangents to the graph... okay. So basically, we have tangents on f of x, and one thing we want to do here is make those tangents intersect at these particular coordinates. And in doing so, we then want to retroactively figure out where would they have been taken to achieve that. Makes sense why this is going to be a 4 marker. So let's think about things that might matter for that. One is going to probably be our generic tangent line formula itself, right? The p in that formula is going to indicate where we have taken our tangent from. There is also an x and a y in this formula. The y is implicit, it's y equals all of that. So if we want the tangents to intersect at that xy location, then presumably the only thing we care about would be to substitute those x and y's in there. So let's see. Meaning 3, 1, the y value is 7 on 2. And the x value should be -1. Solving for p would therefore solve the would therefore solve for the possible locations that you could take, the possible x locations that you could take that tangent at. Now, those p values are x locations. We want the full coordinates of the point. So with that in mind, we're just going to sub those back into the original function. Why did this feel like it was so much faster? That feels suspiciously fast for 4 marks. Is that it? That's literally it. And 74% of people failed it. Huh. Okay. I guess most people were doing the y equals mx plus c version of trying to get this tangent line, perhaps, and never quite got there, which is why they weren't able to do this as easily, perhaps. But because we told our CAS to just give it to us, and then just sub in the point that we know they need to pass through, well, already we have those p values to work with. Yeah, okay. So I guess putting more working into maybe the y equals mx plus c version of getting that tangent line will help you get your other marks, but ultimately using the thing in the CAS to then actually achieve those locations by which you're taking those tangents at. I did that rather fast. Do we need an explanation as to how this got the answer? Because anything else, like getting the marks for it, I imagine would just be a matter of maybe even showing the working of it a bit. It seems like this must have been quite an old exam to give 4 marks for it. This is tech active, and if we look at like the notes on this, for instance, they don't really show much working themselves. Like they just say, hey, shove this into the generic tangent line formula. Hell, they're even using the one from the previous part that we're already aware of. Like we're already aware in part C, they tell you, hey, show that the tangent equation is this. So you actually already have the tangent equation, so you could just shove your point in there naturally, replacing one of the y's and one of the x's. So now I'm extra confused as to why they didn't attempt it at all. Others did not realize they could have used a result from part C. Yeah. Maybe it was this. Maybe that was another big factor, which gets us this spread here. But that does seem a bit shocking to me that that many people weren't able to get it, but only 52% weren't able to get that one. The drop-off seems a bit odd there, but anyway. If anything else about that needs to be clarified, feel free to ask me. Otherwise, yeah, that's time. Thanks for coming.
Thank you.
No worries.
I've got a question. So, okay, this is did you take biology in while you were doing your BCs?
Nah, bio is not one of my subjects.
Yeah. Wise decision. But I did take it. So we are doing a final SAC thing before the exams, and we have to make a prac of our own.
You have to make a prac.
Yeah, we have to make a prac and then do the thing. So, yeah,
make a prac and do it.
I just want your opinion on a calculation, like a
okay.
weird calculation that I just thought of to make life a bit easier. I want to know if it's correct. So I have to find the surface area of a leaf.
Yeah.
So what I did is that we've got a micrometer caliper thing.
Yep.
So I use that to measure the thickness of a leaf.
Thickness.
And then I found the volume of a leaf by dipping it in water and measuring the displacement of the water.
Yeah, cool.
Yeah. So to find the surface area, I divided it by the thickness.
Okay.
That should get me the surface area, right? Because like volume is length times breadth times height, and I've considered the height as the thickness. So if I divide it by the thickness, I should get the surface area, right?
Yeah, you're getting the because if you're dividing by the thickness, you're dividing by one of those 3 dimensions. So what you're left with is length by width. The only does that do it?
I mean, I'm only considering one side of the leaf.
Oh, then
the
that's
other side
probably fine then. Yeah, because I was wondering maybe if that simplifies things too much, because a surface area of a thing, you have to consider it as a flat plane. Because true surface area of a thing, if it has like bumps and ridges on it, well, does that get factored in by the fact that you've measured the thing itself and got its volume?
I mean,
That's a good question. I think it sounds alright. I'd have to think about it more to like
Okay.
fully validate that, but definitely one of the things I'd be doing in your position would be like looking at other ways that people have measured, because measuring surface area on a thing, no one's going out there and like there's better ways of literally doing it than just literally measuring the area of each of the shapes and trying to find it
Yeah,
using
yeah.
tools. Stuff like what you're doing seems pretty valid to me.
So our biology teacher said that we
Yeah.
can use a graph paper and draw an outline of the leaf
Oh,
and find
sure.
the squares inside.
Yeah, that's not nearly as
That
interesting.
was yeah. So
Still decent, but not nearly as interesting as what you come up with. No, I like it.
yeah.
It sounds pretty plausible to me.
I mean, I'm just finding one side. I mean, there is the problem of like the stem. I mean, water does escape through the stem as well, but not
Water
as much as
escapes through the
the.
stem.
Yeah, I mean, we are measuring the rate of transpiration, so whatever like the amount of water that goes out of the leaf.
Yeah.
So
And
yeah,
does water being absorbed by it offset a little bit how much the volume is displaced? Probably not. I can't imagine it would, because it would just sort of fill up. It sounds pretty plausible. Now, I'm no scientist, unfortunately, and I don't have too much of a background in these sort of things, so don't take my word for it, but just a little bit more confidence, maybe, that what you're doing sounds plausible, at least to me. I would definitely be looking at like other research methods and trying to figure out, well, okay, what methods have people used to find surface areas of non-trivial shapes? Maybe it'll be something to start searching up.
yep,
And if you find something similar to what you've done, then sounds pretty plausible and appropriate. Hell, even ask your actual teacher on it, because at the end of the day, your teacher will be the one that's grading it. So if the teacher doesn't understand your
yeah.
method, then then you're kind of screwed
And
either
the teacher
way.
said it sounded good enough.
The teacher said it was good enough.
Yeah,
Yeah, well, there you go. Right. No, look, it sounded pretty good. Sick.
yeah.
I
I
got
just
some good
want like
ideas
yeah,
between this approach here and your volume approach for getting a surface area. Got some good ideas going on there. I like it.
yeah.
Nice.
Yeah. Okay. I guess leave it to it.
Easy. Alright, best of luck to continue the SAC, and hope the bio thing goes well as well.
Yeah, okay. Thanks.
Thank
Have
you.
a good day.
You too.
Good night.